Okay, so once again, okay. So once again, very good afternoon all. So in the previous lecture, we have started the new chapter, that is chapter number 4, the torsion of the circular shaft. And in the previous lecture, we have discussed about how the shaft is subjected to the torque, and due to that particular torque, how it is subjected to the twisting moment, and due to that particular twisting moment, how it is correlated with the shear stress value and the shear strain value that we have discussed in the previous lecture. That means the shaft is not subjected to the tensile loading, the shaft is not subjected to the compressive loading, but the shaft is the rotating element. Means the shaft is used to transmit the power from one location to the another location by using the chain drive, belt drive, gears, pulleys, etc. But during that particular transmission, what happens? The torque transmission is also happening whenever we are transferring the power from one location to the another location. So in that case, the torque transmission is also taking place. Means the shaft is also transferring, or it is also sustaining the some amount of torque. Means we can say that that shaft is under the torsion. If the shaft is under the torsion, it is subjected to the twisting moment. And if it is subjected to the twisting moment, there is a shear stress and there is a shear strain. If the shaft is unable to transmit the torsion, there is no any development of the torsion, or there is no any development of the shear stress and the shear strain through that particular shaft. Therefore, in order to make that particular shaft under the torsion condition, we have to apply some amount of torque on that particular shaft. And yesterday, and or in the previous lecture, I have given the two examples. If the shaft is fixed at one end and another end is free, then need not require to apply the torque at the fixed end. We have to apply some amount of torque at the free end. Due to that, the shaft becomes under the torsion condition. Similarly, if the shaft is free at the both sides and we are applying the torque at only one side, so in that case, it is not possible to say that the shaft is under the torsion. But in order to make it is under torsion, at the left side also we have to apply the torque. But the torque applied at the left side and the torque applied at the right side both are equal and opposite. Equal means equal in magnitude, opposite in nature. If one is moving, or if one is rotating in clockwise direction, another should be rotating anti-clockwise direction. If it is like that, then and then only your shaft will be in torsion. Okay, so that we have discussed in the previous lecture, and in addition to that, we have discussed the assumptions. Which assumptions, which condition the shaft has to satisfy, because whenever we have to use the any shaft in any particular application, some of the standard cases are there, or some of the standard assumptions are there, or standard conditions are there that shaft has to satisfy. If it is satisfying all those conditions, then and then we are able to calculate the unknown parameters, because sometimes we have to calculate the theta value, we have to calculate the shear stress, we have to calculate the shear strain, we have to calculate the torque, we have to calculate the diameter of the shaft. So in order to calculate all those parameters, what is the first requirement? The shaft has to satisfy all the assumptions. In total 6 assumptions we have discussed in the previous lecture. Okay, so now in the today's lecture we are going to derive the torsion formula. The little bit introduction I have given in the previous lecture, but now how this particular formula is exactly obtained, because this torsion formula we have to use again and again for your further calculation. Same formula we have to use in the different manner. If we have to calculate the power, we have to make some modifications in the torsion formula, we have to use it. If we have to calculate the torque, then again we have to use the same formula. If we have to calculate the diameter of the shaft, again we have to use the same formula. If we have to calculate the theta as an angle of twist, again same formula we have to use for all the types of problems. Therefore, before moving to that particular problems, how this particular formula is actually derived, that derivation we will discuss in the today's lecture. Okay, so in order to solve that particular dimensions, here the one figure is in front of you. First of all, I will explain that particular figure, because through this particular figure, we have to derive our final equation. Okay, now, so the one figure is in front of you. In that particular figure, one shaft is there. So this is the shaft. This is the shaft. So if you see the original figure, so this is the shaft. Okay, the shaft is fixed at one end. So this is the left side of the shaft, that is point A. Or we have considered shaft AB. The point A is present at the left side and the point B is present at the right side on the axis. But to the point I have considered, it is at the left side at the center point of the shaft, and the point B we have considered at the right side at the center point of the shaft. That means we have considered shaft AB whose one end is fixed and another end is free. That means left side of the shaft is totally fixed, that is point A is fixed, and the right side of the shaft, that is point B, it is free. Therefore, that will be considered as a free end, and that free end is subjected to the some amount of torque. You can see here. Here, the T amount of torque is applied at the free end. Now what happened? Due to this particular T amount of torque is applied, somewhat twisting is taking place in this particular shaft. And yesterday I have given the example of hand. If your friend is rotating your hand, there is a something pains. There is a pains in your hand. Why it is happening? Because your hand is also having some limit of rotations. Your hand is also having some limit of the rotation. So up to certain limit, there is not any pains. But if it will reach the maximum limit, then there is a pain, means it exceeds the limit of the twisting movement. प्रमाणापेक्षा जर जास्त हात तुमचा तुमच्या मित्रांना जर ट्विस्ट केला किंवा पिरगळला तर तुमच्या हातामध्ये लगेच काय होतात, पेन होतात. व्हाय इट इज हॅपनिंग? बिकॉज युअर हँड हॅज एक्सीड्स द लिमिट ऑफ द twisting. Similarly, in this particular shaft also, due to the torque applied at the free end, some twisting is also taking place in this particular shaft. Okay, and for that purpose, in order to derive that particular this derivation, these are the two sections considered. If you see the figure number 1, so this is the figure number A, which is called as the longitudinal section. This is the figure number A, which is called as the longitudinal section, and this is the figure number B. In front of that, again, one figure is there, which is called as a cross section. So only one shaft is there, and that shaft is represented in the front side and the right side. This longitudinal section represents the front side of that particular shaft, and in front of that one circle is given. If you see, in front of that one circle is given, that circle represents the right side of that particular shaft. Therefore, here they have mentioned the word longitudinal. Why they have mentioned the word like a longitudinal? Because here the axis of this particular shaft is totally visible. Longitudinal and linear means it is along the axis. The meaning of the longitudinal, meaning of the linear means it is along the axis. Therefore, the first figure is named as a longitudinal section, and second figure, that is figure number B, is named as a cross section. Okay, now what happened exactly after the application of torque T? So due to this particular T amount of torque applied at the free end, the twisting is taking place. And due to that particular twisting, what happened? This point B, which is on the axis, it is shifted to the B dash. See, this is the B dash point. It is in the figure. Due to the T amount of torque is applied at the free end, this shaft will start twisting about their own axis. हा shaft काय होणार आहे? त्याच्या own axis भोवतीच काय होणार आहे? Twist होणार आहे. And due to that twisting movement, this point B is shifted from B to B dash. And if I will join one line, that is A B dash, here you will get one angle. For example, like this. So this is one dotted line. Okay. So this is the dotted line, and this angle you will get. This angle you will get. So why this particular angle you will get? Because I have applied the T amount of torque at the free end, and due to which the twisting of the shaft is taking place, and due to that particular twisting, the point B which is present at the free end, that point B is shifted to the B dash. But there is no any changes at point A. If you see at the left side, there is no any changes at the left side. Why? Because point A is totally fixed. And due to that only, here you will get one angle, and that angle is represented by B dash AB, and that angle is represented by phi. That angle is represented by phi, which is called as a shear strain. Please keep in mind, whatever the phi is taken, phi is indicated, this phi is called as a shear strain. Why it is called as a shear strain? Because your before twisting, your point B is exactly on the center line. Before twisting, the point B is exactly on the center line, but after twisting, the position of point B will get changed, means the distortion of the material is taking place. म्हणजे हा पॉइंट बी ला जो काय पार्टिकल होता मटेरियलचा, तो मटेरियलचा पार्टिकल काय झाला, तर या पॉइंट बी डॅश ला शिफ्ट झाला. Means the distortion of the material is taking place from one point to the another point, and distortion term is related to the change in dimensions. And here this change in dimensions will be represented in the form of strain, but here as the shaft is subjected to the torque, therefore whatever this phi value is indicated on the figure, this phi value is called as a shear strain. So this is visible in the longitudinal section, but in another figure, that is in the point or in the figure B, if you see similarly the point B is also present on the horizontal axis, and due to the same twisting moment, the point B is shifted to the B dash. You can see here. Here also represented. This is the point B, and here also represented B dash. And this angle in the cross section is represented by theta. In figure B, or in the cross section of the shaft, in the second figure, the angle whatever visible in the figure, that angle is represented by theta, and this theta is called as a twisting movement. म्हणजे तुमचा शाफ्ट किती अँगल न ट्विस्ट झालाय, that value will be represented in the second figure, and how much amount of strain induced in the shaft, that will be represented by the figure number A as a longitudinal section. Please understand the difference between the figure number A and in the figure number B. Figure number A and figure number B both are same. फक्त figure number A आपण काय केलेला आहे, त्या शाफ्टचा ॲज अ फ्रंट साइड म्हणून इंडिकेट केलेला आहे, आणि फिगर नंबर B म्हणजे त्याच शाफ्टचा साइड व्ह्यू म्हणून इंडिकेट केलेला आहे. And due to the application of torque, the point B shifted from B to B dash. मग लॉन्जिट्युडिनल सेक्शन मध्ये जो काय आपल्याला अँगल मिळालाय, त्या अँगलला आपण फक्त काय म्हणतोय, शियर स्ट्रेन म्हणतोय, वेअर वी हॅव रिप्रेझेंटेड द डिस्टॉर्शन ऑफ द मटेरियल. बट ड्यू टू द सेम अमाउंट ऑफ टॉर्क, तुमचा तो शाफ्ट किती अँगल न ट्विस्ट झालाय, that also we have to calculate. Then where it is visible, so for in order to represent that particular theta value, we are going to use the second figure. मग शियर स्ट्रेन तर फाइंड आउट केला, मग आपल्याला थीटा जर व्हॅल्यू काढायची असेल तर ती कुठे फाइंड आउट करायची, तर ती फाइंड आउट करण्यासाठी आपण ह्या सेकंड फिगर म्हणजे फिगर बी चा उपयोग करतो, की ज्याच्यामध्ये आपण दिस अँगल इज ऑल्सो रिप्रेझेंटेड बाय थीटा. Therefore, you have to keep in mind the phi is equal to shear strain and theta is called as a angle of twist. And why it is happening? Once again, I am repeating, the shaft having radius r, radius of the shaft will be considered as a r, whose one end is fixed, another end is free, and at the free end we are applying the T amount of torque, and due to that particular torque, distortion of the material is taking place, and you will get the two angles. And in the longitudinal section, whatever the angle you will get in the longitudinal section, whatever the angle you will get, that angle is a phi, which is equal to shear strain. Then which angle you will get, which is equal to angle, what is that, B dash AB, angle B dash AB from figure A. Okay, then theta is equal to angle of twist. Theta is equal to angle of twist. Then which angle? B dash O. This is the point O in the second figure. B dash OB. So angle B dash OB from figure B. Okay, so these are the two angles you will get from the longitudinal section, that is figure number A, and theta as the angle of twist you will get from the cross section, that is figure number B. Okay, so these are the two values we have defined from the given two figures. Now, one more thing, from longitudinal section, from longitudinal section, that is figure A. From longitudinal section, that is figure A, if I have to calculate the tan phi value, if I have to calculate the tan phi value from the figure number A, if I have to calculate the tan phi value, what is the rule of the tan rule? What is the tan rule?
Opposite upon adjacent.
Correct. Front side upon adjacent side. See, front side upon adjacent side. Now please tell me, what is the front side of the tan phi from the figure?
B dash B.
B dash B, correct. Or B B dash, I will consider. B B dash. Divided by, what is the adjacent side?
AB.
AB, correct. बघा, फ्रंट साइड अँड ऍडजस्टंट साइड फ्रॉम द फिगर, म्हणजे ह्या फायच्या समोर कुठली बाजू आहे तर बी बी डॅश. त्या फायच्या ऍडजस्टंट म्हणजे शेजारी कुठली बाजू आहे तर ए बी. दिस इज द इन्क्लाइंड लाईन, दिस इज नॉट अ ऍडजस्टंट साइड, दिस इज द hypotenuse. Getting? This is the hypotenuse. So this value we are not considering as the adjacent side. So the front side of the phi value will be considered as a BB dash and their adjacent side will be considered as a AB. Therefore, you will get tan phi is equal to B B dash divided by AB. But here phi is very small, phi is very small, or it is measured in radian. So whatever the twisting is taking place, so due to this T amount of torque which is applied at the free end, and here you will get one angle as a phi, but that phi value is very less, it is very negligible. जर मॅक्सिमम ट्विस्टिंग जर त्या शाफ्ट मध्ये झालं असतं तर तो शाफ्ट मॅक्सिमम ट्विस्ट होऊन त्या ठिकाणीच काय झाला असता, ब्रेक झाला असता. बट सच सिच्युएशन्स आर नॉट हॅपनिंग इन एनी टाइप ऑफ ऍप्लिकेशन. बघा, ज्या ठिकाणी आपण एखादा शाफ्ट वापरत असतो तो वापरलाय म्हणजे आपण त्या पर्टिक्युलर ऍप्लिकेशनला तो शाफ्ट काय केलेला असतो, डिझाईन केलेला असतो. त्यामुळे देर इज अ व्हेरी लेस चान्सेस ऑफ द फेल्युअर. असे थोडे चान्सेस असतात की ज्या ठिकाणी तुमचा शाफ्ट काय होतो, फेल होतो किंवा तो त्या ठिकाणी break होतो. There are very less chances, but some twisting is taking place, no problem. Some amount of twisting is taking place, but whatever the twisting is taking place or whatever this phi angle you will get for the particular application, it is very less or it is measured in the radian. So radian value is very less. Therefore, as this phi is very small and it is measured in radian, whatever this tan parameter is there from the above equation, that tan parameter we will neglect, and same equation we have to write in the form of phi is equal to B B dash upon AB. B B dash upon AB. Please keep in mind, initially we have applied the tan rule. Tan phi is equal to front side upon adjacent side, which is equal to B B dash upon AB. But from this particular tan phi parameter, whatever the phi value is there, that phi value is very small, or it is measured in radian. Therefore, from this particular term, this tan parameter, we have to neglect it, and same equation we have to write in the form of phi, that is phi is equal to BB dash upon AB. Therefore, BB dash is equal to phi into AB, which is equal to. Then what is the AB distance in the figure? What is the AB distance in the figure?
L.
Length. You can see from this particular point A to the point B, this indicator is represented as a length of shaft. Therefore, same equation I can write as a B dash is equal to phi into length. Keep as this is a equation number 1. Okay, from this particular longitudinal section, we have calculated the value of BB dash, which represents the distortion of the material. Distortion means one point is shifted to the another point due to the T amount of torque applied. Okay, so this the equation number 1 means we have calculated the value of BB dash in the form of phi and L. So this we have calculated from the first figure, that is longitudinal section. Now, from next figure, from figure B, that is cross section of shaft. Cross section of the shaft. जसं फिगर ए चा वापर करून आपण बी डॅश काढला. Similarly, by using the figure B, we have to calculate the B dash. Now, please tell me, in the figure number A, B dash is one of the distance. B dash is one of the distance. But in figure number B dash, whether it is distance or whether it is arc. Arc, because this is the circular section. Arc आहे. This is not a distance. It is not a vertical distance. BB dash high vertical distance आहे. That we have calculated from the figure A. But if you think about the second BB dash value in the figure number B, this is the arc. Because this is the side view of the shaft, and ह्या side view of shaft आपण कशाच्या फॉर्म मध्ये बघतोय तर सर्क्युलर फॉर्म मध्ये बघतोय. आणि त्या सर्क्युलर फॉर्म वर तुम्हाला हा एक आर्क मिळालाय. तो आर्क पर काय इंडिकेट करतोय तर B dash, and that value also we have to calculate from the figure B. म्हणजे जसं फिगर ए चा वापर करून आपण बी डॅश ची व्हॅल्यू काढली, तसंच फिगर बी चा वापर करून पण आपल्याला काय करायचंय, बी डॅश ची व्हॅल्यू काय करायची आहे, फाइंड आउट करायची आहे. Therefore, if I have to calculate the length of arc in bracket B dash is equal to, what is the formula for the length of arc? Can anybody? Length of arc is equal to, I will tell. Length of arc is equal to radius into angle. Radius of shaft into angle subtended. How much amount of twisting is taking place? त्या आलेल्या ट्विस्टिंगला जर आपण रेडियस ने मल्टिप्लाय केलं तर you will get the length of arc, and that length of arc will be considered as a B dash. Then what is the radius from the figure? What is the radius from the figure?
OB dash.
What is the radius? This is the small r. Small r represents the radius. And then what is the angle?
Theta.
Correct. This is the r into theta. So this is the second equation. So what we have calculated from figure number B, that is cross section of the shaft, we have calculated the arc, length of arc as a B dash. In the figure number A, that is the vertical distance, we have calculated by using the tan rule. Similarly, in the figure number B also, if we have to calculate the same distance, but in order to calculate that particular distance, we have to use the formula of arc, because in the figure number B dash distance is represented in the form of arc. Length of arc is equal to, we are having the formula radius of shaft into angle. Then radius of the shaft will be considered as a small r, and theta will be considered as a angle subtended or angle of twist. and you will get the BB dash is equal to R into theta. This is the second equation. And now if you compare BB dash is equal to phi into L. If you compare equation number 1 and equation number 2, their left hand sides are equal. Left hand sides are equal means here also BB dash is present, here also BB dash is present. Therefore, by comparing both equations, that is from above equation 1 and 2 as LHS is equal to RHS. Therefore, R into theta is equal to phi into L. R into theta is equal to phi into L. And if I will write the equation in the form of phi, या फायच्या फॉर्म मध्ये जर मी इक्वेशन लिहिलं तर फाय इज इक्वल टू आर इंटू थिटा, फाय इज इक्वल टू R into theta divided by L, and this is the equation number 3. What I have done, I have compared equation number 1 and equation number 2 with each other. दोन्ही इक्वेशनच्या लेफ्ट साइडला BB डॅश आहे. जर लेफ्ट हँड साइड जर त्याच्या इक्वल असतील तर त्याच्या दोन्ही राइट हँड साइड पण काय होणार, इक्वल होणार. देअरफॉर R into theta is equal to phi into L. मग हेच इक्वेशन मी फक्त काय केले, फायच्या टर्म मध्ये लिहिले. तर मी काय केलं, फाय टर्म ऍज इट इज स्किप केली. दिस L, कॅपिटल L, इट इज प्रेझेंट ऍट द लेफ्ट साइड. ते जर मी इकडच्या बाजूला घेतलं तर ते इकडे काय होणार आहे, डिवाइड होणार आहे. Therefore, you will get the value of phi is equal to R into theta divided by L. Okay, so this is the equation number 3. Now, as per definition of modulus of rigidity, G is equal to. What is the definition of modulus of rigidity? What is the definition of modulus of rigidity?
Shear stress upon shear strain.
Correct. Stress upon strain. This is the common definition. Please keep in mind. Stress upon strain. This is the common definition which is applicable for all the elastic constant. जसं capital E is equal to stress upon strain, capital G is equal to stress upon strain, capital K, bulk modulus, it is also stress upon strain. But which type of stress and which type of strain, that is also very, very important. For capital E, linear stress upon linear strain. For capital G, shear stress upon shear strain. And for capital K, that is bulk modulus, is equal to volumetric stress upon volumetric strain. But that two terms are not important here for this particular chapter. Here we have to use the definition of G as a shear stress upon shear strain. Shear stress upon shear strain. Okay, therefore capital G is equal to shear stress is indicated by tau, and shear strain is indicated by phi. Getting? As per the definition of modulus of rigidity, stress upon strain, this is the common definition, but it is equal to shear stress upon shear stress. And always shear stress is indicated by tau and shear strain is indicated by phi. Therefore, by using this equation, I will write the equation as a phi is equal to tau upon G. This is the equation number 4. म्हणजे काय केलं बघा, रिजिडिटीचा फॉर्म्युला वापरून मी परत अजून फायची व्हॅल्यू काढली. दॅट इज कॅपिटल G इज इक्वल टू टाउ अपॉन फाय. मग तेच इक्वेशन मध्ये मी काय केलं, फक्त आय हॅव रिटन दॅट इक्वेशन इन द फॉर्म ऑफ फाय. मग हे फाय खालच्या बाजूला होतं, ते जर लेफ्ट साइडला घेतलं तर इकडे ते मल्टिप्लाय होणार. अँड G इज प्रेझेंट ऍट द लेफ्ट साइड, इकडे असताना ते मल्टिप्लाय. ते जर मी राईट साइडला घेतलं तर ते G कुठे जाणार आहे, खालच्या बाजूला जाणार आहे. Okay, and now if I will compare equation number 3 and equation number 4, from equation 3 and 4, again LHS is equal to RHS. Therefore, R into theta divided by L is equal to tau upon G. R into theta divided by L into is equal to tau upon G. तेच इक्वेशन मी जर थोडंफार टर्म रिअरेंज केल्या तर काय येते बघा, tau upon R is equal to G theta by L. म्हणजे काय केलं, हो जो काय जी टाऊच्या खालच्या बाजूला जो काय जी होता तो जी काय केला मी लेफ्ट साइडला घेतला. जर तो लेफ्ट साइडला घेतला तर तो वरच्या बाजूला जाणार, न्यूमरेटरच्या साइडला जाणार. ओके, आणि इकडचा आर, हा आर जर मी राईट साइडला घेतला तर इकडे असताना तो मल्टिप्लाय आहे. जर मी तो इकडच्या बाजूला घेतला तर तो कुठं काय होणार आहे, तर इकडच्या बाजूला डिवाइड होणार आहे. त्यामुळं टाऊ डिवाइड बाय आर इज इक्वल टू G theta by L. That equation I will write here. That is tau upon R is equal to G theta by L. And this will be considered as a equation number. So now this is the equation we have derived. Okay, that is tau upon R is equal to G theta by L. That means half derivation we have derived. If you see our original derivation, tau upon R is equal to, sorry, T upon J is equal to tau upon R is equal to G theta by L. त्याच्यामध्ये ज्या काही दुसऱ्या दोन टर्म आहेत कुठल्या, tau upon R is equal to G theta by L, that half derivation we have derived from the longitudinal section and the cross section of the figure. That means 50% derivation we have derived. That R will be considered as a radius. R will be considered as a radius. Sometimes that R is represented by small r, and sometimes that R is represented by the capital R. And always in our final equation that R will be represented as a capital R. Why? Because whatever the torque is applied on the rotating shaft, that torque is always maximum at outer periphery. Please keep in mind. तुमचा जो काय टॉर्कची व्हॅल्यू असते, टॉर्कची व्हॅल्यू कायम इट इज मॅक्सिमम ऍट आउटर रेडियस. मग आउटर रेडियस कुठल्या बाजूला असणार आहे, तर शाफ्टच्या बाहेरच्याच बाजूला असणार आहे. जरी तो शाफ्ट हा सॉलिड इन क्रॉस सेक्शन असेल किंवा जरी तो शाफ्ट हा हॉलो इन क्रॉस सेक्शन असेल, तरी पण दोन्ही शाफ्ट साठी टॉर्कची व्हॅल्यू इट इज मॅक्सिमम ऍट आउटर पेरिफेरी. मग शाफ्ट जर सॉलिड असेल तर दॅट आर इज रिप्रेझेंटेड बाय कॅपिटल आर, आणि जर तोच शाफ्ट हॉलो असेल तर दॅट आर इज रिप्रेझेंटेड बाय आर ओ, कॅपिटल आर ओ. कॅपिटल आर मीन्स रेडियस अँड ओ मीन्स आउटर डायमीटर. त्यामुळे तुम्ही कॅपिटल आर लिहिलं काय किंवा आर ओ लिहिले काय, दोन्ही शाफ्ट साठी टॉर्क इज मॅक्सिमम ऍट आउटर पेरिफेरी. Please keep in mind this assumption is also very, very important. Okay, I think there is a electricity problem, so I am unable to share the screen. Just to wait, we will wait for the 1 or 2 minutes. Is my voice is audible? Please check. My voice is audible. Please check.
Yes, sir.
Okay. 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 So we have calculated the equation, that is tau upon r is equal to g theta by L. This is the equation number 6. But as I have told, whatever the torque is applied or whatever the torque is developed in the rotating shaft, it is always maximum at the outside diameter. That shaft may be solid in cross section, that shaft may be hollow in cross section, but whatever the torque we are applying or whatever the torque is developing in the rotating shaft, it is always maximum at the outer periphery. Therefore, same above equation I will write, that is tau upon capital R is equal to g theta by L. That is equation number 6. Once again, डेरिव्हेशन मध्ये डिराइव्ह करण्यासाठी आपण स्मॉल आर ऍज अ रेडियस कन्सिडर केलं होतं, पण तेच इक्वेशन आपल्याला इन द फॉर्म ऑफ कॅपिटल आर मध्ये रिप्रेझेंट करायचंय. व्हाय? बिकॉज व्हॉट एव्हर द टॉर्क इज अप्लाइड, व्हॉट एव्हर द टॉर्क इज डेव्हलप्ड इन द शाफ्ट, इट इज मॅक्सिमम ऍट द आउटर पेरिफेरी. मग आउटर पेरिफेरी म्हणजे शाफ्टचा कुठला डायमीटर येणार आहे, तर एक्सटर्नल डायमीटर येणार आहे. जर त्याच्यामध्ये सॉलिड शाफ्ट असेल तर तो सॉलिड शाफ्टसाठी फक्त एकच डायमीटर असतो, तो म्हणजे कुठला, कॅपिटल डी. जर त्या कॅपिटल डी जर आपण रेडियस मध्ये कन्वर्ट केलं तर तो झाला कॅपिटल आर. जर तुमचा शाफ्ट हॉलो असेल तर त्याचा आउटसाइड डायमीटर काय येणार आहे, कॅपिटल डीओ. जर त्याची आपण रेडियस मध्ये कन्वर्ट केलं तर दॅट विल बी रिप्रेझेंटेड बाय कॅपिटल आर ओ. त्यामुळे जर तो सॉलिड असेल तर टाऊ अपॉन कॅपिटल आर इज इक्वल टू जी थिटा बाय एल. जर तो हॉलो असेल तर टाऊ अपॉन कॅपिटल आर ओ इज इक्वल टू जी थिटा बाय एल. इट्स डिपेंड्स अपॉन द which type of shaft is used for the particular application. Okay, so this is the equation number 6, and from that we have derived our half derivation. What is our half derivation? Tau upon r is equal to, sorry, t upon j is equal to tau upon r is equal to g theta by. That means this 50% part we have derived from this particular longitudinal section and the cross section of the figure. Now we have to think about the first part, that is t upon j, how it is to be developed or how it is to be calculated. So for that purpose, the further section of the shaft is considered for the further derivation. Now what is the further section? Now if you see the second figure, in this particular figure, one elemental ring is considered in the shaft. Whatever the shafts we have considered previously as a longitudinal section and the cross section, same shaft we are considering for the further derivation, but in that particular shaft one elemental ring is considered. त्याच shaft मध्ये आपण काय करायला लागलोय बघा, तर एक elemental ring consider करायला लागलोय. See, this is the elemental ring, means one small portion. We are considering one small portion of the shaft for the further derivation, and that elemental ring having radius as a small r and the cross sectional area dA. बघा ह्याच्यामध्ये हा कॅपिटल आर, this capital R represents the radius of shaft and the small r represents the radius of elemental ring. Now in this particular elemental ring, how much amount of torque is developed, that we are going to calculate. ह्या elemental ring मध्ये किती टॉर्क इंड्यूस झालेला आहे, तो टॉर्क व्हॅल्यू आपल्याला काय करायचे आहे, फाइंड आउट करायचे आहे. and whatever torque value we are calculating for this elemental ring, तीच व्हॅल्यू आपल्याला काय करायची आहे, शाफ्टला कन्सिडर करायची. जे ह्या इलेमेंटल रिंग मध्ये किती टॉर्क इंड्यूस होणार आहे ती टॉर्क व्हॅल्यू आता आपण काय करणार आहे फाइंड आउट करणार आहे आणि ती आलेली टॉर्क व्हॅल्यूज आपण ह्या टोटल शाफ्ट साठी काय करणार आहे तर कन्सिडर करणार आहे. व्हाय इट इज लाईक दॅट? बिकॉज दिस इलेमेंटल रिंग इज वन ऑफ द स्मॉल पार्ट ऑफ द शाफ्ट. ही इलेमेंटल रिंग कुठं आपण शाफ्टच्या बाहेर कन्सिडर केलेलं नाहीये. दिस इलेमेंटल रिंग इज वन ऑफ द स्मॉल पार्ट ऑफ द शाफ्ट. त्यामुळं ह्या इलेमेंटल रिंगचे जे काय आन्सर येतील जे काय उत्तर येतील ते सगळे आन्सर इट इज ऍप्लिकेबल फॉर द टोटल शाफ्ट. पण ते डेरिव्हेशन करण्यासाठी आपण शाफ्ट साठी डायरेक्ट टॉर्क व्हॅल्यू काढू शकत नाही. त्यामुळं त्याच शाफ्ट मध्ये आपण हे एक रिंग कन्सिडर केलंय की ज्या रिंगचं रेडियस स्मॉल आर आहे त्याचा क्रॉस सेक्शनल एरिया डी आहे. Then how it is to be calculated? How it is to be calculated? So for that purpose already we are having one formula. See, we have tau upon r is equal to g theta by L. Therefore tau is equal to r into g theta by L. This is the equation number 7. काय केलं बघा? We have this equation 6 which is derived from the previous two figures. Tau upon small r is equal to g theta by L. In the same equation, what I have done? I have written the equation in the form of tau. I have written the equation in the form of tau only. That means this r value I have taken to the right side. मग इकडे असताना लेफ्ट साइडला असताना r कुठे आहे? डिनॉमिनेटरच्या साइडला. ते जर मी राइट साइडला घेतलं तर ते काय होणार आहे मल्टिप्लाय होणार आहे. therefore r or small r is equal to g theta divided by L, and this tau value represents shear stress in shaft or ring. This tau value represents the shear stress of shaft or shear stress induced in the ring. Why? Because ring is one of the part of this particular shaft. हा रिंग पोर्शन आपण कुठे कन्सिडर केलाय त्याच शाफ्ट मध्ये कन्सिडर केलाय. मग त्या शाफ्ट मध्ये जर टाऊ एवढा शियर स्ट्रेस इंड्यूस होत असेल आणि त्याच शाफ्ट मध्ये जर हा इलेमेंटल रिंग जर आपण कन्सिडर केलेला असेल तर जेवढा शियर स्ट्रेस हा शाफ्ट मध्ये इंड्यूस झालेला आहे तेवढाच शियर स्ट्रेस आपण त्या रिंग मध्ये पण आहे असं पण काय करू शकतो कन्सिडर करू शकतो. That's why whatever the shear stress is induced in the shaft, that shear stress we are considering for the ring also. Okay, now the shear stress we have calculated. Now if I have to calculate force on elemental ring, if I have to calculate force on elemental ring, and that force will be represented by dF. Therefore dF is equal to, now please tell me the formula. The stress value we are having, cross sectional area we are having, then how to calculate the force?
Tau into dA.
Correct. See, stress is equal to force upon area. हे इक्वेशन सगळ्यांना माहित आहे. स्ट्रेस इज इक्वल टू फोर्स अपॉन एरिया. जर आपल्याला ह्या इक्वेशन पासून जर फोर्स काढायचा असेल तर फोर्स इज इक्वल टू स्ट्रेस इनटू एरिया. इफ स्ट्रेस इज इक्वल टू फोर्स इंटू एरिया, जर असं इक्वेशन आपल्याला माहित असेल तर त्याच इक्वेशनचा वापर करून आपण फोर्सची व्हॅल्यू काढायची असेल तर काय करणार, फोर्स इज इक्वल टू स्ट्रेस इंटू एरिया. म्हणजे काय एरिया जे काय डिनॉमिनेटरला आहे ते जर तुम्ही इकडच्या बाजूला केलं तर ते मल्टिप्लाय होणार. दॅट इज डीएफ इज इक्वल टू स्ट्रेस इंटू एरिया. Therefore dF is equal to, what is the stress value? What is the stress value? What is the stress in the elemental ring?
Tau.
Tau. And what is the area of the elemental ring?
dA.
dA. It is represented on the figure. See, whatever the tau value we have calculated for the shaft, तीच टाऊची व्हॅल्यू आपण इलेमेंटल रिंगला पण कन्सिडर करतोय का? तर इलेमेंटल रिंग इज वन ऑफ द स्मॉल पार्ट ऑफ द शाफ्ट. ती इलेमेंटल रिंग त्या शाफ्टच्या मटेरियलमध्येच आपण कन्सिडर केलेलं आहे. त्यामुळं जेवढी काय स्ट्रेसची व्हॅल्यू शाफ्ट मध्ये इंड्यूस झालेली आहे तेवढीच शियर स्ट्रेसची व्हॅल्यू त्या इलेमेंटल रिंग मध्ये पण असणार आहे. That's why by using the stress value of the shaft or by using the stress value of the ring, we are able to calculate the force on the elemental ring. That is, force is equal to stress into area. Now put the value. dF is equal to, tau value is equal to R into G theta by L into dA. Write down from equation 7. We have calculated the dF value. Now torque on elemental ring. Torque on elemental ring, and that torque will be represented by dt. Tell me the formula of torque.
Force into perpendicular distance.
Torque formula I have given. Torque is equal to force into perpendicular distance. तसा फोर्सचा फॉर्म्युला स्ट्रेस इंटू एरिया आपण कशावरून काढला? तर त्या टॉर्क मधलं आणि सेंटर पॉइंट मधलं डिस्टन्स म्हणजे तुमचं काय असणार आहे? रेडियस ऑफ शाफ्ट. दॅट इज टॉर्क इज इक्वल टू फोर्स इंटू परपेंडिकुलर डिस्टन्स. मीन्स हियर dt is equal to, what is the force value we have calculated? dF. What is the perpendicular distance between the torque and the center point? What is the perpendicular distance between the torque and the center point? What is the perpendicular distance of the torque and the center point of the shaft? I am telling the shaft. I am not asking for the elemental ring. What is the torque? For example, if I am calculating the torque here, focus on the elemental ring. ह्या इलेमेंटल रिंग वर जर हा टी अमाउंट ऑफ टॉर्क जर असा अप्लाय झाला असेल तर ह्या इलेमेंटल रिंग वर अप्लाय झालेला हा टॉर्क आणि त्याच्या सेंटर पॉइंट मधलं डिस्टन्स, व्हॉट इज इट इंडिकेट? Radius, correct. Therefore, force into perpendicular distance means force already we have calculated and radius will be considered as a perpendicular distance. Therefore, dt is equal to, what is the dF value we have calculated? That is R into G theta by L into R. Therefore, dt is equal to R square into G theta by L into dA into dA. It is remaining into dA. That is R into G theta into dA and into multiply by R. So you will get this as a torque value. Now, as we have to calculate the torque value in the form of capital T, what is our requirement? We have to calculate the torque value in the form of capital T. So, integrating above equation. Integrating above equation. Therefore, integration of dt is equal to g theta by L. This is the constant term. Please keep in mind. G is constant, theta is constant, length is constant. Remaining term r square into d. Okay, and integration of r square into dA is equal to capital J is equal to polar moment of inertia. आर स्क्वेअर इंटू इंटिग्रेशन ऑफ आर स्क्वेअर इंटू डीए, ह्यालाच आपण काय रिप्लेस करतोय तर जे ऍज अ पोलर मोमेंट ऑफ इनर्शिया. देन इंटिग्रेशन ऑफ डीटी, व्हॉट इज इंटिग्रेशन ऑफ डीटी?
T.
As a capital T. Okay, g theta by L, this is the constant term as it is, g theta by L into integration of r square into dA means your capital J. And if I will write the equation in the form of हे J right side ला, हे जर मी left side घेतलं तर it will get divide, that is T upon J is equal to g theta by L. And this is your equation number 8. This is your equation number 8. And what is our equation number 6? What is our equation number 6? Tau upon R is equal to
G theta by
G theta by L. This is the equation number 7. And now if you compare left hand side and the right hand side, here the right hand side are same. G theta by L is also present in the equation number 8. G theta by L is also present in the equation number 7. And if I am comparing both the equations, I can say that T upon J is equal to tau upon R is equal to G theta by L. And this is your torsion formula. And in this particular torsion formula, this capital T represents the torque induced in the shaft or torque induced in the elemental ring. Shaft and elemental ring हे वेगळे वेगळे पार्ट नाहीत. Whatever the elemental ring we have considered, that elemental ring will be considered in the same shaft. त्यामुळे जे काय रीडिंग तुमच्या शाफ्टला येतील ते आपण इलेमेंटल रिंगला कन्सिडर करतोय, जे काय रीडिंग तुमच्या इलेमेंटल रिंगला येतील तेच आपण काय करतोय शाफ्टला कन्सिडर करतोय. फक्त ह्या डेरिव्हेशन मध्ये असे स्मॉल पार्ट आपल्याला डेराइव्ह करण्यासाठी काय करावे लागतात, कन्सिडर करावे लागतात. मग जे काय रीडिंग तुमचं शाफ्टला येईल, सॉरी जे काय रीडिंग तुमचे इलेमेंटल रिंगला येतील ते सगळे रीडिंग तुमच्या शाफ्टला पण ऍप्लिकेबल असतील. त्यामुळे अशा डेरिव्हेशन मध्ये आपण त्या शाफ्ट मध्ये एखादा पार्ट कन्सिडर करतो, स्मॉल पोर्शन कन्सिडर करतो आणि त्या स्मॉल पोर्शनचे आन्सर्स विल बी ऍप्लिकेबल फॉर द टोटल सेक्शन. And if you see the T upon J is equal to tau upon R is equal to G theta by L. T is equal to torque, J is called as a polar moment of inertia, tau is called as a shear stress, R is called as a radius of shaft. जर ह्या ठिकाणी शाफ्ट हॉलो असेल तर ह्याच R ला आपण काय म्हणायचं, फक्त RO म्हणायचं, म्हणजे आउटर रेडियस ऑफ द शाफ्ट. G is the modulus of rigidity, theta is the angle of twist, and L is the length of shaft. So this is the derivation of the torsion formula. So this derivation we have obtained in the two different conditions or two different portions. So initially we have considered the two figure of the shaft. One is longitudinal section and another is a cross section. मग त्या longitudinal section चा वापर करून आपण BB dash हे आन्सर फाइंड आउट केलं. Similarly figure B चा वापर करून we have calculated the distance BB dash as a arc. मग दोन्ही इक्वेशन मध्ये BB dash कंपेअर करून त्याच्यामध्ये both दोन्ही इक्वेशन सेम दाखवून you will get one phi value. Okay, phi value we have calculated. Again we have used the formula of the modulus of rigidity or its definition. What is that? Shear stress upon shear strain. मग shear stress आपण tau ने इंडिकेट केला, shear strain आपण phi ने इंडिकेट केला. त्याच्यामध्ये पण परत तुम्हाला phi ची व्हॅल्यू मिळाली, ते इक्वेशन phi मध्ये कंपेअर केलं. मग अगेन वी आर कंपेअरिंग द phi इक्वेशन and you will get the half equation as a tau upon R is equal to G theta by L. Okay, and then for further derivation we have considered one small elemental ring. मग त्या elemental ring मधला स्ट्रेस ऑलरेडी आपण फाइंड आउट केलेला आहे, तो म्हणजे कुठला, तर पहिलं 50% डेरिव्हेशन म्हणजे tau upon R is equal to G theta by L. मग that same equation I have written in the form of tau as equation number 7. बघायचं दिसतंय तुम्हाला. This is the equation number 7. हे इक्वेशन काय इंडिकेट करते तर शियर स्ट्रेस इंड्युस्ड इन द शाफ्ट. मग त्याच शाफ्ट मध्ये आपण एक एलिमेंटल रिंग कन्सिडर केली आहे, त्यामुळं दिस शियर स्ट्रेस इज ऑल्सो ऍप्लिकेबल फॉर द एलिमेंटल रिंग. मग त्या शियर स्ट्रेसचा वापर करून आणि त्या एलिमेंटल रिंगचा एरियाचा वापर करून आपण त्याच्यावर अप्लाय झालेला फोर्स काढला. त्याच्यासाठी फॉर्म्युला काय वापरला, स्ट्रेस इज इक्वल टू फोर्स अपॉन एरिया. तर फोर्स इज इक्वल टू स्ट्रेस इंटू एरिया. मग स्ट्रेस ऑलरेडी आपण काय काढलेला आहे, टाऊ व्हॅल्यू. एरिया ऑफ रिंग इज ऑलरेडी गिवन dA. We have kept the value. We got one equation. After calculation of force, again we have to calculate the torque on elemental ring. Torque on elemental ring formula we have. Torque चा basic formula आपल्याला माहित आहे. Torque is equal to force into perpendicular distance. ओके, मग फोर्स किती काढलेला एलिमेंटल रिंग वरचा, तर dF एवढा. ओके, आणि परपेंडिक्युलर डिस्टन्स म्हणजे ह्या एलिमेंटल रिंगच्या वरच्या बाजूला बघा, ह्या एलिमेंटल रिंगच्या वरच्या बाजूला टी अमाउंट टॉर्क आपण अप्लाय केलेला आहे. मग त्या टॉर्क मधलं म्हणजे ह्या एलिमेंटल रिंगची आउटर पेरिफेरी आणि त्याचा सेंटर पॉइंट म्हणजेच इट रिप्रेझेंट्स द डिस्टन्स बिटवीन टॉर्क अँड द ऍक्सिस ऑफ रोटेशन. बघा फिगर मध्ये मी दाखवलेला आहे. कॅपिटल टी इज अप्लाइड ऑन द एलिमेंटल रिंग. मग तो कुठल्या बाजूला अप्लाय केलाय, तर ह्या एलिमेंटल रिंगच्या आउटर पेरिफेरीला. मग त्या आउटर पेरी पासूनचं त्या ह्याचं सेंटर डिस्टन्स म्हणजे परपेंडिक्युलर डिस्टन्स बिटवीन टॉर्क अँड द सेंटर पॉइंट, अँड दॅट इज रिप्रेझेंटेड बाय स्मॉल r. Therefore dt is equal to force into perpendicular distance. मग फोर्स ची व्हॅल्यू तुम्हाला माहिती आहे, परपेंडिक्युलर डिस्टन्स तुम्हाला r माहिती आहे. We have written equation. But you got the equation in the form of dt. I want it in capital T as a torque. मग काय केलं, we have integrating that equation. ज्या काय कॉन्स्टंट टर्म आहेत त्या कॉन्स्टंट टर्म बाहेर घेतल्या आणि त्याच टर्म मध्ये इंटिग्रेशन ऑफ r square into dA, it is replaced by the polar moment of inertia. And then further you will get the equation number 8 as a T upon J is equal to G theta by. मग आलेलं इक्वेशन आपण इक्वेशन 7 शी जर कंपेअर केलं, जर तुमच्या राईट हँड साइड जर ह्या दोन्ही इक्वल येत असतील तर तुमच्या ह्या लेफ्ट हँड साइड पण काय असणार आहेत, इक्वल असणार आहेत. Therefore I can say that T upon J is equal to tau upon R is equal to G theta by L. मग त्याच्यामध्ये J ची व्हॅल्यू जे काय असते, पोलर मोमेंट ऑफ इनर्शिया, that J is equal to pi by 32 into d raised to 4. This is for solid shaft, and J is equal to pi by 32 into do raised to 4 minus di raised to 4. This is for hollow shaft. मग दिलेला शाफ्ट कुठला आहे, जर सॉलिड असेल तर पाय बाय 32 इंटू कॅपिटल डी रेस टू 4 मीन्स ओनली वन डायमीटर. नंतर दिलेला शाफ्ट जर हॉलो असेल तर तो पाय बाय 32 इंटू कॅपिटल डीओ रेस टू 4 मायनस स्मॉल डी आय रेस टू 4. So these are the polar moment of inertia formulas which we have to use during the calculation, and this is the torsion formula, that is T upon J is equal to tau upon R is equal to G theta by L. Getting everyone? Have you understood this particular formula, how it is derived in the two conditions? So initially two figures as a longitudinal section and the cross section, ज्याचा वापर करून आपण 50% फॉर्म्युला ह्या ठिकाणी डिराइव्ह केला. आणि मग त्याच शाफ्ट मध्ये एक एलिमेंटल रिंग कन्सिडर करून त्या एलिमेंटलचा स्ट्रेस आपल्याला माहित आहे, स्ट्रेसचा वापर करून फोर्स काढला, फोर्सचा वापर करून टॉर्क काढला आणि त्या टॉर्कला परत आपण इंटिग्रेट केलं आणि तुम्हाला टी अपॉन जे हा कन्सेप्ट मिळाला. आणि ते दोन्ही इक्वेशन कंपेअर करून यू विल गेट द फायनल इक्वेशन ॲज अ टी अपॉन जे इज इक्वल टू टाउ अपॉन आर इज इक्वल टू जी थीटा बाय एल. Getting everyone? Have you understood this derivation?
Yes, sir.
Okay. What about others? Is everyone has understood? If you have not understood, you can unmute and you can ask the questions. Sir, how this step is coming like this? Is everyone has understood? If it is understood, try to give the reply so I can clear the thing that everyone has understood the derivation. Actually, now this is for online examination. For your MCQ examination, this derivation will not ask. But based on this derivation, 101% one MCQ question will be there. Please keep in mind. What is the torsion formula? आणि त्याच्यामध्ये चार ऑप्शन दिलेले असतात. T upon J is equal to tau upon R is equal to G theta by L. किंवा काय काय वेळेस T upon tau is equal to tau upon R is equal to L upon G theta. किंवा G into tau divided by tau into J. Like that, any variations they will made in the formula and they will ask the correct answer. What is the correct torsion formula? But sometimes the option will be given like this. T upon J is equal to tau upon R is equal to C theta by L. And please keep in mind the capital G, modulus of rigidity, is also represented by capital C. Please keep in mind. त्यामुळे काही वेळा ऑप्शन इन द फॉर्म ऑफ कॅपिटल जी मध्ये दिले असतील. समटाइम्स ऑप्शन विल बी गिवन इन द फॉर्म ऑफ कॅपिटल सी, बट डोंट डू एनी कन्फ्युजन. जरी सी असेल त्या ठिकाणी यू हॅव टू चूज द करेक्ट ऑप्शन. जरी जी असेल देन ऑल्सो यू हॅव टू चूज द correct option as a T upon J is equal to tau upon R is equal to G theta by L or C theta by L. So this is the torsion formula. If your examination will be offline as per the university rules, 101% this derivation will be asked for 7 to 8 marks. But now this is not theoretical examination, it is MCQ based, but for MCQ questions also this derivation, this formula is also very important. Okay, I hope everyone has understood. Still, if anybody is having any problem, you can ask. So I got very few replies in the chat box. What about others? Near about 80 students are there. And what about others? Whether they have not understood or they are not attending the lectures, or they are attending just for attendance purpose. Is everyone has understood? Once again, I'm asking. If you have understood, then only we will go further. If you have not understood, or if you are not giving the replies, so I'm also in confusion whether you have understood or not. If your reply is like yes, so definitely it will be understood to you all. And still, during your own study, if you are having any problem, anytime you can ask me. I will be available there to give the answers of your questions. Okay. So now I got the many replies in the chat box. So the derivation is very simple. It is straightforward process. In the notes, whenever I am sending the notes, that detailed derivation is available in that. But now you just understood the concept, how it is to be derived. And for that particular derivation, how to use the longitudinal section, how to use the cross section, and then how to use your third figure as a elemental flame. Okay, so this is the derivation of the torsion formula. Okay, now we'll discuss about the next two important points, that is strength of the shaft. What is meant by the strength of the shaft? What is meant by the strength of shaft? And if I have to measure the strength of the shaft, which parameter I have to measure? For example, if I have to measure the strength of any component which is subjected to the loading. Now in this particular shaft, the load is not applicable. आपण shaft मध्ये कुठल्याच प्रकारचा external load apply करत नाही. It may be tensile, it may be compressive. But suppose if I will give one example, if one body is there and that body is subjected to the some amount of external load, and I have to check the strength of that particular body. So what I will do? By using that particular external load and by using the cross-sectional area of that particular body, I am going to calculate their tensile stress, I am going to calculate their compressive stress, I am going to calculate their deformation, I am going to calculate their change in length, then I am going to calculate the volumetric stress. So like that, number of parameters I will calculate for that particular component, and from that I can say that this is the strength of that particular body. The tensile stress is equal to 60 Newton per mm square and compressive stress is equal to 35 Newton per mm square. From this particular stress value, I can define how much amount of strength of that particular body is there. But in case of a shaft, it may be solid or it may be hollow in cross section. How to check the strength of that particular shaft? How to check the strength of that particular shaft? Because the shaft is one of the rotating element. The shaft is one of the rotating element which will transmit the power. Also, it will transmit the torque from one rotating element to the another rotating element. For example, see, this is one shaft. This is one shaft which is connected to motor. For example, this is the motor. This is the second shaft. Okay, then this is the third shaft. This is the fourth shaft. Okay, so what I have to do, once I will start the motor, this shaft number 1 will start rotate. This shaft number 1 will start rotate. It may be in clockwise, it may be in anti-clockwise direction. Don't worry about that. But it will start rotate. Okay, now if I have to transmit the power of this particular shaft number 1 to the shaft number 4, or if I have to transmit the power of shaft number 1 to the shaft number 2 and then to the shaft number 3. So initially there is no any contact between shaft number 1, 2, 3, 4. Only motor is started and the shaft number 1 is also start rotating. But if I have to transmit the power, what I will do, I will connect either pulley or I will connect one gear between the shaft number 1 and 2 like this. I will connect like this. Then I will connect the shaft number 2 and shaft number 3 by using the second gear. Again, I will connect the shaft number 3 and shaft number 4 by using the third gear. So once I will start the motor, then shaft number 1 is also start rotating. And once the shaft number 1 is start rotating and it is connected to the shaft number 2 by using the gear, so the shaft number 2 is also start rotating. Once the shaft number 2 is start rotating, it is connected to the shaft number 3 through the second gear. So power is transmitted from the second to third. Again, the third is connected to the fourth shaft. Again, the power is transmitted through the gears. So like that, the power transmission is also taking place by using that particular shaft. If the shaft is not available, then we are unable to use the pulley, we are unable to use the chain drive, we are unable to use the belt drive, we are unable to use the gears. In order to hold this component as a pulley, gear, belts, so this shaft plays very important role. Means the shaft is one of the rotating element which is used to transmit the power or which is used to transmit the torque from one rotating element to the second rotating element. म्हणजे shaft number 1 हा one rotating element, shaft number 2 second rotating element, shaft number 3 third rotating element, shaft number 4 fourth rotating element. That means I have transmit the power from shaft number 1 to the shaft number 4. Means here there is a some torque transmission also taking place. ज्या ठिकाणी आपण पॉवर ट्रान्समिट करतो त्याच ठिकाणी तुमचा टॉर्क पण एका शाफ्ट पासून दुसऱ्याकडे, दुसरीकडून तिसरीकडे, तिसरीकडून फोर्थ, like that transmission will be taking place. And if I have to check the strength of the shafts, I am calculating how much amount of power is transmitted by the shaft or how much amount of torque is transmitted by the shaft. If I have to check the strength of the shaft, I am calculating the power transmission capacity and I am calculating the torque transmission capacity. And for power transmission, we are having the formula P is equal to 2 pi nt divided by 60. This is the power formula. Keep in mind. P is equal to 2 pi nt upon 60. जर त्या शाफ्टचा जर आपल्याला टॉर्क माहित असेल, तो किती स्पीडने फिरतो हे जर माहित असेल, तर त्या शाफ्टची आपण किती पॉवर ट्रान्समिट करतोय, that also we are going to calculate. Or by using the same formula, जर त्या शाफ्ट मध्ये आपल्याला पॉवर माहित असेल, then we are able to calculate the टॉर्क असतो. म्हणजे टॉर्क जर माहित असेल तर तुम्ही पॉवर काढू शकता, पॉवर माहित असेल तर तुम्ही टॉर्क काढू शकता. वी आर कॅल्क्युलेटिंग दिस टू पॅरामीटर मीन्स वी आर चेकिंग द स्ट्रेंथ ऑफ द शाफ्ट. जसं एखाद्या बॉडीवर आपण एक्सटर्नल फोर्स अप्लाय करतो आणि त्या एक्सटर्नल फोर्स मध्ये जर त्याच्यामध्ये टेन्साइल स्ट्रेस असेल, कॉम्प्रेसिव्ह स्ट्रेस असेल, दॅट व्हॅल्यू वी आर कॅल्क्युलेटिंग मीन्स वी आर चेकिंग द स्ट्रेंथ ऑफ दॅट पर्टिक्युलर बॉडी. Similarly, in this particular shaft application or in this particular rotating shaft, if the shaft is transmitting the power from one element to the another element, if it is transmitting the torque from one element to the another element, and we are calculating that parameter, means we are checking the strength of the shaft. म्हणजेच जर तुम्हाला एखाद्या शाफ्टची स्ट्रेंथ जर मेजर करायची असेल तर तो शाफ्ट किती पॉवर ट्रान्समिट करतोय किंवा तो शाफ्ट किती टॉर्क ट्रान्समिट करतोय ह्या व्हॅल्यू आपण काढतोय. म्हणजेच वी आर चेकिंग द स्ट्रेंथ ऑफ द शाफ्ट. मग त्याच्यामध्ये द स्ट्रेंथ ऑफ शाफ्ट विच इज सॉलिड. जर तुम्हाला सॉलिड शाफ्टची जर स्ट्रेंथ चेक करायची असेल आणि स्ट्रेंथ चेक करायची म्हणजे तुम्हाला पॉवर काढायची असेल तर पॉवर काढण्यासाठी तुम्हाला अगोदर टॉर्क काढणं गरजेचं आहे. तर सॉलिड शाफ्टसाठी टॉर्कचा फॉर्म्युला आहे कॅपिटल T इज इक्वल टू पाय बाय 16 इंटू tau max into capital D cube. Take this particular formula in your notebook. If we have to check the strength of solid shaft, we have to calculate their torque transmitting capacity as well as power transmitting capacity. मग पॉवर ट्रान्समिटिंग कॅपॅसिटी जर तुम्हाला फाइंड आउट करायची असेल तर पॉवरचा फॉर्म्युला काय आहे 2 पाय nt अपॉन 60. मग टी ची व्हॅल्यू आपल्याला माहित आहे काय नाही तर दॅट टॉर्क ट्रान्समिटिंग कॅपॅसिटी और दॅट टॉर्क ऑफ द सॉलिड शाफ्ट विल बी calculated by using the formula capital T is equal to pi by 16 into tau max into dq. So you put the heading strength of the shaft in bracket solid shaft and write down this particular formula, that is capital T is equal to pi by 16 into tau max into dq. Shaft मध्ये आपण टेन्साइल स्ट्रेस फाइंड आउट करू शकत नाही. In the shaft we are not calculating tensile stress, compressive stress, their volumetric stress. We are not calculating this parameter because shaft is not subjected to the external load. Shaft is the rotating element and it is mostly used for the power transmission application. That's why I have given this example, shaft 1 2 3 4. ह्या सगळ्या शाफ्ट जर आपल्याला स्ट्रेंथ चेक करायची असेल तर प्रत्येक शाफ्टची आपल्याला पॉवर ट्रान्समिटिंग कॅपॅसिटी म्हणजेच कॅपिटल P काढावा लागतो किंवा त्याच शाफ्टचा जर आपण टॉर्क फाइंड आउट केला तर आलेले व्हॅल्यू वी कॅन से ॲज अ स्ट्रेंथ ऑफ सॉलिड शाफ्ट. So you put the heading strength of the shaft in bracket solid shaft. You draw the figure also if it is required. But figure is not required. Figure is represented just for your understanding purpose how it is looking like. But here the formula is very important. This formula is very important. It is also asked for the MCQ questions. The torque transmitted by solid shaft dash 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 4 options. Capital T is equal to pi by 16 into tau max into d cube. Capital T is equal to pi by 18 into tau max into d raised to 4. Capital T is equal to pi into tau max into capital T. Capital T. Capital T is equal to pi by 34 into tau max into d raised to 5. Like that, variations of the answers will be given in the 4 options, but out of that we have to choose the correct option as a pi by 16 into tau max. Sometimes this tau max is also represented by only tau. Tau max means maximum stress in the shaft. Tau max means maximum stress in the shaft, or it is also represented by tau. And into d cube, this is very important. Whether it is d cube or d raised to 4 or d square or d raised to 6, that is also very important. So strength of the solid shaft is equal to capital T is equal to pi by 16 into tau max into d cube. So this is applicable for the solid shaft because only one diameter is there in the formula. मग हे आलेला टॉर्कचा फॉर्म्युला जर तुम्ही ह्या पॉवरच्या इक्वेशन मध्ये ठेवलं तर you will get the power transmitting capacity also. And by using these two parameters, we can check the strength of the solid shaft. Then next, strength of hollow shaft. Now instead of using the solid shaft, now in some applications I have used the hollow shaft. In some application, I will use the hollow shaft. Then here also I have to check the strength of the hollow shaft. Again, same parameter I have to calculate. If I have to check the strength of the hollow shaft, again I have to calculate their torque transmitting capacity and I have to calculate their power transmitting capacity. So power formula we are having, it is same for both, 2 pi nt divided by 60. So this formula is applicable for the solid shaft also as well as hollow shaft also. But there is a change in the torque transmission capacity or torque formula. And for the hollow shaft, you are having the formula capital T is equal to pi by 16 into tau max into bracket do raised to 4 minus di raised to 4 divided by du. So this is the formula. If the shaft is replaced from solid to hollow, their torque formula will get changed. And that torque formula will be available in the form of two diameters. बघा दोन्ही फॉर्म्युल्यामध्ये pi by 16 is common. Tau max is common, tau max is common. But if you check the last parameter as a diameter, the effect of diameter also plays very important role in the torque calculation. Therefore, in case of a solid shaft, only d cube term is there, and in case of a hollow shaft, you are having the two diameters as a do raised to 4 minus di raised to 4 divided by only do. And by using this formula, we can calculate the torque transmitting capacity of hollow shaft. This torque value we can put in the power formula, and you will get the power transmission capacity also. Means again, for the strength of the hollow shaft, we have to calculate their torque transmitting capacity and their power transmitting capacity in order to check the strength of hollow shaft. Concept is same for both solid and for the hollow section, only formulas are different. And now, which shaft is more preferable? Whether solid shaft is more preferable in application or hollow shaft is more preferable in application, that understanding is also very important. Okay, the hollow shaft is more preferable in the industry, or it is mostly suitable in application. Why? Because in case of a hollow shaft, their central portion is hollow. In case of a solid shaft, the shaft is totally solid. It is having only outer diameter. It is having only outer diameter, and in case of a solid shaft, the torque is maximum at the outer periphery. So solid असू द्या किंवा hollow असू द्या. For both solid and the hollow shaft, the torque is maximum at the outer periphery. In case of a solid shaft, the shear stress is maximum at the center point. In case of a solid shaft, the shear stress is maximum at the center point. Because it is solid in section म्हणजे solid shaftच्या center positionला पण तुमचं मटेरियल प्रेझेंट असणार आहे. मग ज्या ठिकाणी मटेरियल आहे त्या ठिकाणी ऑब्वियसली स्ट्रेस हा इंड्यूस होणार आहे. But if you think about the hollow shaft, in case of a hollow shaft, their central portion is totally hollow. Their central portion is totally hollow. Therefore, at the center point of the hollow shaft, the shear stress will be equal to 0. Why it is 0? कारण hollow shaftच्या center positionला तो hollow असल्यामुळे त्याच्या ठिकाणी कुठलंच मटेरियल त्या ठिकाणी प्रेझेंट नसणार आहे. That's why, तर if there is a material is not present, तर हवेमध्ये स्ट्रेस इंड्यूस होत nahi. Therefore, in case of a hollow shaft, at the center point, the shear stress is equal to 0. And in addition to that, in case of a hollow shaft, त्याचा जो काही सेंटरचा hollow portion आहे, that hollow portion we can use for another application. म्हणजे त्या hollow portion मध्ये आपण दुसरा shaft insert करून त्याचं दुसरं कुठलं तर आपण application त्या ठिकाणी वापरू शकतो. Therefore, the hollow shaft is more preferable in the various applications. What is the reason? Because in case of a hollow shaft, at the center point, the shear stress is totally equal to 0, because at the center point, the portion is totally hollow, means material is not present. If material is not present, then there is no any development of stress. पण ते जर तुम्ही सॉलिड शाफ्ट घेतला तर सॉलिड शाफ्टच्या सेंटरला पण मटेरियल प्रेझेंट असणार आहे, म्हणजे त्या ठिकाणी स्ट्रेस इंड्यूस होणार आहे आणि त्या सॉलिड शेपचा सेंट्रल पोर्शन आपण युटिलाइज करूच शकत नाही का, तो त्या ठिकाणी हॉलो नाहीये. बट इन केस ऑफ ए हॉलो शाफ्ट, त्याचा सेंट्रल पोर्शन हा हॉलो असल्यामुळे त्या शाफ्ट मध्ये आपण दुसरा शाफ्ट इन्सर्ट करून त्याचं दुसऱ्या ऍप्लिकेशन साठी त्या ठिकाणी यूज करू शकतो. दॅट्स व्हाय द हॉलो शाफ्ट इज मोर प्रेफरेबल दॅन द सॉलिड शाफ्ट. Sometimes in some of the application only solid shaft is useful. In some of the application only hollow shaft is useful. But If you think about the comparison, the hollow shaft is more preferable. I'm not saying hollow shaft is used in the various types of application. I'm saying word preferable. The hollow shaft is more preferable than solid shaft in particular applications. What is the reason? These are the two reasons. कुठं शियर स्ट्रेस असतो आणि कुठं शियर स्ट्रेस नसतो, किंवा सॉलिड शाफ्टचा आपण पोर्शन यूज करू शकत नाही, त्याच ठिकाणी हॉलो शाफ्टचा पोर्शन आपण दुसऱ्या ऍप्लिकेशन साठी यूज करू शकतो. बट इन बोथ द शाफ्ट द टॉर्क इज मॅक्सिमम ऍट द आउटर पेरिफेरी. प्लीज कीप इन माइंड, जो काही शाफ्ट मध्ये टॉर्क इंड्यूस होणार आहे तो टॉर्क त्या शाफ्टच्या आउटर पेरिफेरी म्हणजे आउटर डायमीटरला इट इज ऑलवेज मॅक्सिमम. सॉलिड शाफ्टचा आउटर डायमीटर म्हणजे टी, कॅपिटल डी म्हणजेच रेडियस कॅपिटल आर, आणि हॉलो शाफ्टचा आउटर डायमीटर म्हणजे डीओ, कॅपिटल डीओ, आणि त्याचीच रेडियस म्हणजे कॅपिटल आर. सो दिस इज द comparative study of the solid shaft and the hollow shaft. Okay, I hope you have taken this particular two formulas: strength of solid shaft pi by 16 into tau max into d cube, then strength of hollow shaft pi by 16 into tau max into du raised to 4 minus dr raised to 4 divided by du. And through these formulas we can check the strength of the solid shaft and the hollow shaft. Yes, have understood how to calculate the strength of solid shaft and the hollow shaft. Strength calculate करायची म्हणजे आपल्याला कुठले पॅरामीटर काढायचे आहेत. For that purpose these two formulas are important, and these formulas are important for your MCQ questions also. So this should be at your tip of tongue. जर तुम्ही du raised to 4 dr raised to 4 च्या ऐवजी त्या ठिकाणी du cube dr cube जर ऑप्शन सिलेक्ट केला तर your answer will be wrong. Okay, yes, understood, and have taken this particular two headings and their formulas in your notebook?
Yes, sir.
Okay, is everyone, you please take, I will give few minutes, 1 minute for your writing. Strength of shaft in bracket solid shaft, capital T is equal to pi by 16 into tau max into d cube. And for the hollow shaft, capital T is equal to pi by 16 into tau max into du raised to 4 minus dr raised to 4 divided by du. Okay, I hope everyone has taken this particular formulas in your notebook. If you have not taken, immediately take the list of the formulas. Capital T, again I will give the list of the formulas which are required for the solving the numericals, but now these concepts are very, very important. Strength of shaft, how it is to be checked, means we are measuring the torque and we are measuring the power. Sometimes the shear stress also will be considered as the strength of the shaft. एखाद्या shaft मध्ये shear stress किती आहे आणि दुसऱ्या shaft मध्ये shear stress किती आहे. So that shear stress is also one of the part of the strength of the shaft. But maximum focus, as it is rotating element, the maximum focus is given on the power transmitting capacity and the torque transmitting capacity. ज्या ठिकाणी तुमचा shaft rotate होत असतो त्या ठिकाणी power पण transmit होत असते आणि torque पण एका shaft पासून दुसऱ्या shaft वर ट्रान्सपोर्ट होत असतो. जर तो ट्रान्समिट होताना if your shaft will get break, म्हणजे shaft is not having the torque transmitting capacity, तो shaft तुमचा टॉर्क सस्टेन करू शकत नाही, म्हणजेच तुमचा shaft काय होतो त्या ठिकाणी ब्रेक होतोय, म्हणजेच इट इज हॅव्हिंग द मॅक्सिमम ट्विस्टिंग. जास्तीत जास्त तो शाफ्ट त्या ठिकाणी ट्विस्ट होतोय, म्हणजेच दॅट शाफ्ट इज हॅव्हिंग द लेस टॉर्क ट्रान्समिटिंग कॅपॅसिटी. जेवढी त्याची टॉर्क ट्रान्समिटिंग कॅपॅसिटी जास्त असणार आहे तेवढा तो शाफ्ट मॅक्सिमम पॉवर किंवा मॅक्सिमम टॉर्क काय करणार आहे, ट्रान्समिट करणार आहे विदाउट एनी डिफॉर्मेशन. जर डिफॉर्मेशन होत असेल there is a less torque transmitting capacity, means strength of the shaft is less. Straight forward statement, जर शाफ्ट तुमचा ब्रेक होत असेल तर त्याची टॉर्क ट्रान्समिशन कॅपॅसिटी कमी असणार आहे, म्हणजेच शाफ्ट इज हॅव्हिंग द लेस स्ट्रेंथ. आणि जर तुमचा शाफ्ट मॅक्सिमम पॉवर मॅक्सिमम टॉर्क जर ट्रान्समिट करत असेल विदाउट एनी डिफॉर्मेशन, कुठलंच डिफॉर्मेशन न होता जर ह्या सगळ्या गोष्टी जर तो अचीव करत असेल तर स्ट्रेंथ ऑफ शाफ्ट इज हाय. Okay, now this is the list of the formulas. So take this particular list. Type number 1, what are the problems we are going to solve in the type number 1? So for that purpose, this is the list of the formulae. So write down type number 1, problems on torque and power transmitted by shaft. Problems on torque and power transmitted by shaft. In this particular type number 1, we have to calculate the torque induced in the shaft. We have to calculate the power transmitted by shaft. Sometimes we have to calculate the shear stress induced in the shaft. So what is the formula number 1? Here I have written the torsion formula. T upon J is equal to tau upon R is equal to G theta by L. First formula, take in your notebook. T upon J is equal to tau upon R is equal to G theta by L. In front of that I have written ह्या टॉर्शनच्या फॉर्म्युला मधला जो काय कॅपिटल T असतो त्यालाच आपण T max म्हणतोय. Whatever the T is represented in the torsion formula, that T will be considered as a T max. Means the maximum torque value of the shaft. म्हणजे एखादा शाफ्ट किती पर्यंत टॉर्क तुमचा ट्रान्समिट करू शकतो? फॉर एक्झाम्पल 80 न्यूटन mm. So this 80 Newton mm represents the T max value. Means the shaft can sustain or it can transmit the torque up to 80 Newton mm only. Means less than 80, that is 79, 75, 60, 5, 10, any value that shaft can transmit. But if your torque value exceeds the limit of 80, suppose same torque is transmitting the torque as a 90 Newton meter, 90 Newton per mm. So it will exceed the limit of shaft and there is a possibility of failure. That's why in a particular application, ज्या ठिकाणी आपल्याला shaftचा यूज करायचा आहे त्या ठिकाणी according to that application, first of all we have to design the shaft. त्यामुळे प्रत्येक ठिकाणी shaftचे diameter वेगवेगळे. बघा आपल्या गाडीचा axle घेतला, diameter is different. Two wheeler axle different. In lathe machine, axle is different. Shaft diameters are different. So for that particular application, that shaft is designed. So for that purpose, initially we have to decide that up to which value the shaft has to transmit the torque. जर तो 80 न्यूटन पर mm पर्यंत जर आपल्याला डिझाइन केलेला असेल तर त्या शाफ्टने फक्त 80 न्यूटन पर mm एवढाच काय करू शकतो? ट्रान्समिट करू शकतो. जर त्याच्या लिमिटच्या जर बाहेर जर तो शाफ्ट ट्रान्समिट करायला लागला तर एक कंडिशन असेल की देयर इज अ पॉसिबिलिटी ऑफ फेल्युअर. Therefore, whatever the capital T is represented in the torsion formula, that is also called as a T max. Please write in front of that formula, capital T is equal to T max. Then second formula, power formula, just now I have told, capital P is equal to 2 pi nt divided by 60. Capital T is equal to 2 pi nt divided by 60, and in front of that particular formula, the capital T is equal to T mean. Write down in front of that particular formula. पॉवरच्या फॉर्म्युलामध्ये जो काय कॅपिटल टी इंडिकेट केलेला आहे त्या टी ला आपण काय म्हणतोय तर टी मीन. मीन्स मीन टॉर्क. मीन्स द टॉर्क विच इज कॅल्क्युलेटेड फॉर पर्टिक्युलर पॉवर व्हॅल्यू. बघा इथं जर पॉवर मी 30 किलोवॅट दिली तर ह्या 30 किलोवॅटला किती टॉर्क आलाय? That torque means your T mean. मग फॉर एक्झाम्पल ह्या 30 किलोवॅटला जर तुमचे T mean ची व्हॅल्यू किंवा ह्या टॉर्कची व्हॅल्यू जर 30 न्यूटन mm एवढी असेल, 30 न्यूटन mm, आणि त्या शाफ्टचं मॅक्सिमम लिमिट 50 न्यूटन mm असेल तर दिस 50 न्यूटन mm रिप्रेझेंट्स द T max. This 50 Newton mm represents the T max, means maximum torque transmitting capacity of the shaft. पण त्या शाफ्ट मध्ये किती टॉर्क इंड्यूस झालाय तर 30 न्यूटन mm, which is less than 50. Therefore, it can be easily transmitted. Therefore, please keep the difference between T max and the T mean. T max represents the maximum torque transmitting capacity of that particular shaft, and पॉवरच्या फॉर्म्युल्यामध्ये जो काही कॅपिटल टी दिलेला आहे त्याच टी ला आपण टी मीन पण म्हणतोय that T min will be calculated for particular power value. मग पॉवर व्हॅल्यू चेंज झाली तर तुमचा टी मीन पण काय होणार आहे, चेंज होणार आहे. 30 वरून 40 गेला, टी मीन विल गेट चेंज. 40 वरून 50 गेला, टी मीन विल गेट चेंज. सो दिस इज द डिफरन्स बिटवीन द मीन टॉर्क अँड मॅक्सिमम टॉर्क. जसं आपण पहिल्या दुसऱ्या चॅप्टर मध्ये बघितलं, द स्ट्रेस डज नॉट एक्सीड 150 न्यूटन पर एम एम स्क्वेअर. व्हॉट इज द मिनिंग ऑफ डज नॉट एक्सीड? म्हणजे 150 न्यूटन पर एम एम स्क्वेअरच्या पेक्षा जास्त स्ट्रेस तो सस्टेन करू शकत नाही. मीन्स इट रिप्रेझेंट्स द मॅक्सिमम लिमिट ऑफ द मटेरियल. सिमिलरली इन द शाफ्ट देर इज अ लिमिट फॉर द टॉर्क. मग त्यामध्ये टी मॅक्स काय आहे अँड टी मीन काय आहे, दॅट वी हॅव टू अंडरस्टूड. त्यामुळे टॉर्शनच्या फॉर्म्युल्यामधला जो काही टी आहे दॅट विल बी द टी मॅक्स, अँड पॉवरच्या फॉर्म्युल्यामध्ये जो काही टी आहे दॅट विल बी टी मीन, विच इज कॅल्क्युलेटेड फॉर द पर्टिक्युलर power which is given in the statement. In addition to that, if power is in watt, ही पॉवर किती दिले 30 किलोवॅट, त्याला आपण वॅट मध्ये काय करणार 30 into 10 raised to 3. If power is given in kilowatt, we are converting in watt. If the power is in watt, whatever the T you will get from the power formula, it will be in Newton meter only. Please keep in mind. जर पॉवरच्या फॉर्म्युलेमध्ये तुम्ही पॉवर किलोवॅट मधून वॅट मध्ये कन्वर्ट केली आणि त्या पॉवरच्या फॉर्म्युलेमध्ये ठेवली ती व्हॅल्यू, आणि त्याच्यापासून जे काय तुम्हाला टी किंवा टी मीन मिळणार आहे दॅट विल बी इन न्यूटन मीटर ओनली. आणि त्या आलेल्या आन्सरला फक्त आपल्याला काय करायचं आहे 10⁻³ न मल्टिप्लाय करून तो टॉर्क तुम्हाला न्यूटन एम एम मध्ये काय करायचं आहे कन्वर्ट करायचं आहे. सो राइट डाउन दिस पर्टिक्युलर वन लाइन बिलो द सेकंड फॉर्म्युला. इफ पॉवर इज इन वॅट, if power is in watt, then if power is in watt, then T mean is in Newton meter. Then T mean is in Newton meter. But all the values we have to take in Newton mm. जर न्यूटन मीटरचं जर न्यूटन एम एम मध्ये करायचं असेल, ऑलरेडी न्यूटन तर आहेच, जर मीटरचं जर एम एम मध्ये करायचं असेल तर परत त्याला 1000 न काय करायचं आपल्याला मल्टिप्लाय करायचं. ओके, सो दॅट स्टेप इज व्हेरी व्हेरी इम्पॉर्टंट ड्युरिंग सॉल्विंग द प्रॉब्लेम्स. सो प्लीज कीप इन माइंड, जरी तुम्ही पॉवर वॅट मध्ये केलेली असेल तरी पण आलेला टॉर्क हा फक्त न्यूटन मीटर मध्येच येतोय, त्याला परत 10⁻³ न मल्टिप्लाय करून आपल्याला काय करायचंय न्यूटन एम एम मध्ये कन्वर्ट करायचं. Okay, then in the torsion formula you are having the value of J, polar moment of inertia, and already I have given for the solid shaft. Write down the third formula, polar moment of inertia. It is represented by J, or sometimes it is represented by IP. Polar moment of inertia is represented by J, capital J, or sometimes it is represented by IP. And write down these two formulas: pi by 32 into d⁻⁴ for the solid shaft, and pi by 32 into do⁻⁴ minus di⁻⁴. Separate ⁻⁴ is there. त्यामुळे do minus di bracket ⁻⁴, it is totally wrong. Sometimes students are doing the calculation like that. Pi by 32 bracket मध्ये do minus di divide आणि bracket ⁻⁴. That calculation will be wrong. do⁻⁴ separately, di⁻⁴ separately. This is for the hollow shaft, and then write down the formula number 4. Torque transmitted. Something's mic is on, Diptesh. Someone's mic is on, Diptesh. Then write down the formula number 4. Torque transmitted. That is strength of the solid shaft and strength of hollow shaft. We are having the two formulas. Capital T is equal to pi by 16 into tau max into d cube. And second formula, pi by 16 into tau max into do⁻⁴ minus di⁻⁴ divided by capital Do. This is for the hollow shaft. And these two formulas are applicable. Strength of shaft. strength of the shaft. So this is the list of the formulae which will be sufficient to solve the problems based on the type number 1, where we are going to calculate the torque, power, and sometimes the shear stress value. But during that particular calculation, which values are important? That is T is equal to 2 max, T is equal to T min. In the power formula, the power is in watt. You will get the T in Newton meter. Again, you have to multiply by 10 raised to 3. You will get in Newton. So this is the list of the formulas for the type number 1. So you take down this particular list in your notebook. So take this particular list. If you have not taken, below the second formula, write down that sentence. If power is in watt, T min will be in Newton meter only. So you have to multiply by 10 raised to 3 there immediately, and that Newton mm value we have to use for the further calculation. Okay, have you taken this list? Yes, have you taken the list of the formulas in your notebook? Type number 1.
Yes, sir.
Okay. Okay, those who have not taken, take it immediately within 1 minute, so we can go further. We will solve one problem if possible. I am receiving replies maximum from only girl students. What about boys? Whether they are in meeting physically or just for attendance purpose, I don't know. Your replies are very, very important. Through your replies, I know whether you are understood or not. So within 1 or 2 seconds are required to give the replies in the chat box. So through that replies, I understood that you are taking the things, you are understood the things, you are getting whatever I am explaining. Okay, good. Now they are sending the replies. Okay. Okay. So this is a list of the formulas. Now we'll take 1 or 2 problems based on this particular type number 1. So the problems are very simple, and whatever this type number 1 is there, it is also very, very important for your EMCQ examination or this online examination, because within 1 or 2 steps you will get the answer. Within 1 or 2 steps you will get the answer. Therefore such problems are also asked in your MCQ examination. The statement is given. In that statement all the values are given and the 4 options are given in the form of answer. So you have to read that particular formula, you have to use the direct formula, and immediately you have to calculate the answer, and whatever the answer you will get after the calculation, that answer you have to compare with the 4 options, and that answer will be there in the 4 option. मग त्या 4 ऑप्शन मधला आपल्याला करेक्ट आन्सर काय करायचं आहे, क्लिक करायचं आहे. So this type number 1 is mostly useful for your MCQ examination also. Okay, so I will take the first problem. I will read the statement first. See, this is the problem number 1. Find the torque which a solid shaft of 50 mm. Find a torque which a solid shaft of 50 mm diameter can safely transmit if the shear stress is not to exceed 180 Newton per mm square. Full stop. There is one shaft. Which shaft is there? Solid shaft is there. First of all, we have to check whether given shaft is solid in section or given shaft is hollow in section. So here clear cutly they have mentioned the shaft is solid, and that solid shaft is having one diameter, that is only one diameter, 50 mm, and their shear stress not to exceed 180 Newton per mm square. And meaning of not to exceed means this is the maximum limit of the shaft. Means this shaft can sustain the stress up to 180 Newton per mm square. Means which value is given here? Which value is given?
Tau max.
tau max. This understanding is very important. Tau max. Tau तर दिलेला आहेच, but instead of using the word as only tau, tau is equal to max. Tau max. तो कशावर ओळखायचा? The shear stress not to exceed. म्हणजे ह्या 180 न्यूटन पर एमएम स्क्वेअर पेक्षा जर तुमचा स्ट्रेस हा मॅक्सिमम झाला तर त्या शाफ्टने तुमचं मॅक्सिमम लिमिट काय केलं? क्रॉस केलं. मीन्स देर इज अ पॉसिबिलिटी ऑफ फेल्युअर. मग असा शाफ्ट त्याचं डायमीटर 50 mm आहे, मॅक्सिमम लिमिट ऑफ द स्ट्रेस इज 180 न्यूटन पर एमएम स्क्वेअर आहे. देन हाऊ मच अमाउंट ऑफ टॉर्क दॅट शाफ्ट विल ट्रान्समिट, दॅट वी हॅव टू calculate. So if I will write down the given parameters, d is equal to 50 mm, then tau is equal to tau max is equal to 180 newton per mm square, and we have to calculate the torque. Means we have to calculate the strength of the shaft. आता इथे आपण टॉर्कची व्हॅल्यू काढतोय, त्या शाफ्टनं किती टॉर्क ट्रान्समिट केला, that value we are calculating. Means we are checking the strength of the shaft. Means here which formula we have to use? Capital T is equal to which formula we have to use
into tau max
Correct.
into d cube.
Pi by 16 into tau max into d cube. Okay, so pi by 16 as it is into tau max 180 into d cube 50 cube. So you will get torque is equal to
4.41 into 10 raised to 6.
4.41 into 10 raised to 6. What is the unit of the torque? What is the formula for the torque? Force into perpendicular distance. मग force चे unit काय असणार आहे? Newton. Perpendicular distance कशामध्ये असणार आहे?
mm.
That means unit of the torque is Newton mm. This is the torque transmitted by the solid shaft. That means whatever the shaft is mentioned in the statement, that shaft can easily transmit this much amount of torque. That is 4.41 into 10 raised to 6 Newton mm. So this is the formula which we have to use. Or sometimes if we have to use the torsion formula, T upon J is equal to tau upon R. T upon J is equal to tau upon R. टॉर्शन फॉर्म्युला आपल्याला माहिती आहे, T upon J is equal to tau upon R is equal to G theta by L. हा पण फॉर्म्युला आपल्याला माहिती आहे. ह्या दोन्ही फॉर्म्युला मधले आपण हे पहिलं कॉम्बिनेशन जर यूज केलं तर बघा, कॅपिटल T J म्हणजे काय असणार आहे? पाय बाय 32 into 50 raised to 4 is equal to टाऊ किती दिलाय? 180. रेडियस डायमीटर दिलाय 50, म्हणजे रेडियस काय असणार आहे? 25. तर एन टॉर्कची व्हॅल्यू किती येते मला सांगा जरा. फक्त कॅल्क्युलेशन पार्ट इज इन्क्रीजिंग. जे आपल्याला सेपरेट काढावं लागणार आहे, पाय बाय 32 d raised to 4. What will be the torque value for this by using this torsion formula? Direct formula we are having to calculate the torque transmitting capacity in the form of strength. But what will be the answer through this calculation? Whether it is same or different?
Same.
That means we can use any formula. Either I can use the torsion formula or either I can use the direct torque formula for your further calculation. त्यामुळे हा टॉर्शनचा फॉर्म्युला इट इज व्हेरी व्हेरी इम्पॉर्टंट. हा आलाय कशापासून? तर हाच टॉर्शनचा फॉर्म्युला यूज करून आपण हा फॉर्म्युला डिराइव्ह केलेला आहे. बट दिस डेरिव्हेशन इज नॉट पार्ट ऑफ युअर सिलेबस. हा T is equal to pi by 16 into tau max into d cube. हा फॉर्म्युला आला कुठून? तर हा फॉर्म्युला डिराइव्ह करण्यासाठी आपण हाच टॉर्शनचाच फॉर्म्युला आपण काय केलेला आहे? वापरलेला आहे. दॅट्स वाय दिस टॉर्शन फॉर्म्युला इज व्हेरी व्हेरी इम्पॉर्टंट. वी आर युजिंग सेम फॉर्म्युला बाय रिअरेंजिंग द टर्म. हाच फॉर्म्युला आपण फक्त वेगवेगळ्या टर्म मध्ये काय करतोय? इंडिकेट करतोय, रिअरेंज करतोय त्याच्या सगळ्या व्हॅल्यू अँड वी आर युजिंग फॉर द पर्टिक्युलर calculation. Okay, so this is the one sample problem where we have calculated the torque transmitting capacity of the solid shaft. And for that purpose, either we can use the torsion formula or either we can use the direct torque formula. But it will be better to use the direct torque formula, which is available with you as a strength of solid shaft and the strength of hollow shaft. And within 1 or 2 steps, you will get the answer. Okay, so this is the one sample problem that we have taken, and with this today we will stop here. Remaining variety of the problems that we will take in the next lecture. Thank you.